Good afternoon, fancy meat computers. How's everybody doing today? Hope you're all doing well today. Sound check, sound check. Am I coming in? Am I coming through? The other class was complaining that I was clipping a little bit, so I turned the gain down a little bit on the microphone. How's this for the audio? Is everybody good with this? Seems good. Seems fine. Everybody likes. Everybody likes. Excellent, excellent, excellent. Good. So, let's see. Let me see if we have any announcements today. Might have announcements. It's entirely possible. Okay, I posted this January 13th. Today is the 14th. We haven't had a class since I posted this, so yes. Is Jupiter up yet? Can't seem to log in. Jupiter should be up, so if you can't log in, please get in contact with Mark or David or Sarth. One of the TAs will be happy to help you out with that. Good, good, good. So, so yesterday I received a directive. Well, all of us who are instructors received a directive. We received a directive from the vice provost's office to come up with a contingency plan for self-isolating. Basically, given the large number of people who are finding themselves in a situation where they have to self-isolate with the latest coolest variant that's been going around of the virus. Essentially, it's important for us to have a plan in case you can't come into school physically, if that was a thing anyway. This is the intention with this plan is that it will continue past the point of our return to in-person classes, which incidentally is still they haven't moved the goalposts on that one just yet. So the plan still is for as of the 31st of January for us to be back to in-person classes. So this will be the policy for the entirety of the class past that point as well. So, first of all, we've formed a plan within the sort of grade team or the course team. All the TAs and myself, we have a plan if any of us, have to be sick for a little bit. For you guys, fortunately, this class is one of the easier ones to keep in an online state. So essentially, if you're in self-isolation and you're still able to work because you're not particularly sick, you'll be expected to keep up with the course via the various online ways of interacting with the course that you should be used to certainly by the time we go back. So there's an online tutorial. All of the tutorials are online at the moment, but we will maintain a tutorial section which is specifically online all the way through this entire course offering. So you can still participate in the tutorials. Secondly, let me just turn off that baby monitor. There we go. Ha! That's there we go. Don't need that coming through on the stream. Yes. So tutorials will be fine. Once we go back to in-person classes, we will be video recording the lectures and posting them to this same YouTube channel. So if you want, like if you have to isolate, you won't miss lectures because those lectures will be still online. So you won't miss anything. Obviously, the assignments, tests, and exam are also set up for online distribution, so you don't have to worry about any of that stuff either. Basically, this is a perfectly fine. This course you have been able to take this course from your bedroom, basically since COVID started, and I at the beginning of the course I sort of thought it prudent to continue these sorts of things and continue to offer sort of the parallel online thing. So, long story short, if you have to self-isolate, minimal impact. So this is what we're going to do, though, if you're actually sick. The university in that email has put forth, you may have heard of this already, but I'll just repeat it in case you hadn't. The MSAF applicability period has been extended to 5 days now. So it used to be 3 days, and so temporarily they're expanding it to 5 days. So if you don't know what that means, previously, or when you have applied an MSAF, any assessments which are due within a 3-day period, all of those you can apply the MSAF to, regardless of which course, however many courses they are. If you didn't know that, that's totally a thing. They're expanding that window to 5 days now from 3. So, as I'm aware, the number of MSAFs that you have available to you has not changed. However, I expect they'll probably be a little bit more flexible with the request for second MSAF process, which is totally a process that already existed that has to go through the faculty office, whatever faculty you're in. So, yeah, so essentially the existing procedures are being adapted to this new state of existence. You don't have to worry about too much otherwise. Yeah, one question. Should we have started the first assignment yet, or will we learn more about those in our later lectures? You don't have to start the... I don't really seriously expect people to be working on assignments until the week in which they're due. So, all of the assignments are due on a Sunday. My expectation is that you take the week before that Sunday and work on the assignment, and not just cram it all in Sunday evening. So I would say you're perfectly fine to have not started assignment 1 just yet. In fact, you may find the content of today's lecture rather illuminating in that respect. So, generally speaking, assignment 1 is based on the topic 2 lecture material, expressions, which we will cover in depth next week. Good. Any other questions? And I didn't just call you a meat computer, I called you a fancy meat computer. There's a big difference between fancy meat computers and regular ones. Okay. Well, nobody seems to have any questions, so... how am I today? Someone's trying to distract me from getting to the lecture material. I'm doing very well today, thank you. I had some time today to begin working on stuff that I have been putting off for way too long. So I'm happy that I have finally arrived at a place in my life where, I can do that, work on that project that I've been meaning to for quite some time. So, flowcharts. So, in yesterday's lecture, we sort of discussed in general what an algorithm is, how we consider an algorithm to be a good algorithm, and all kinds of stuff like that. But now we're going to talk a little bit about how algorithms are actually constructed. So, one very useful sort of early on abstraction that you can use in order to help you think through the process of programming is you can use flowcharts that represent the different symbols that you can write in code. So one of the best pieces of advice that I can give anyone who is trying to learn not just programming, but really anything in the STEM field, sort of the STEM area, is draw it. Right? So I'm going to teach you how to draw an algorithm. So, algorithms can be formulated textually as flowcharts. Flowcharts connect instructions and conditions. So, it is not my expectation that you'll still be using flowcharts by the time you get to the exam for this course. I expect, think of flowcharts as being a stepping stone into understanding how algorithms work. Eventually, you need to outgrow the need for them, right? Possibly by the time we hit topic 3, 4-ish. But for now, it's useful to think in terms of flowcharts to get you into programming, right? So, flowcharts connect instructions and conditions. So instructions can be any number of things, generally statement, command, or action. So, for example, how long does it take to produce an output for a particular input? We would have such instructions as turn a green light on, continue straight ahead, or subtract V from U. In terms of programming itself, these statement blocks can be pretty much any command. Testing. Let's see here. Am I back yet? I'm back. Okay, good. Excellent. Yeah, my computer just decided to crash for some reason. Weird. I guess I've had it on too long. Where's my slides? Slides. PDFs. Topic 1. Bing, bang, boom. Yeah, I don't know. It was like, unexpected forced reset. Yeah. There we go. Well, I mean, sure, it did, my system did just need to reset itself, but, the whole process took, it only took about 20 seconds for the computer to reboot, so, try that with Windows. If Windows had decided to reset my computer, it would probably take half an hour to do a Windows update. Cleared up after a bit. Yeah, if it's so when the stream got interrupted, it probably the buffering took a hit. Let me take a look here. How blurry are we? This isn't bad for me normally, but yeah, the quality seems to be 360 at the moment. So yeah, let me see if there isn't anything I can do on my end. Yeah, there's really nothing I can do about it. If it's sufficiently fuzzy that that it's going to interfere with your participation in the lecture, try either refreshing the page or setting the quality higher. It may have bumped you down to a lower quality. Okay, we've got 720p pretty consistently, so that's good. Okay. Cool. All right. Anyway, so I guess not sure how much of this I lost. So instructions, right? These boxes typically, at least for the next little bit, these will be setting variables to particular values. So when we program, we have a very, very important fundamental instruction called assignment, right? So how it works basically is when you're programming, you use variables. We call them variables, but they're not variables in the algebraic sense, right? In algebra, when you have a variable, that variable, we call it a variable because it may have a number of different values, right? Solve for x. Many of the algebra problems that many of the algebra problems that we've had so far in your education, those would have been of the form solve for x, solve for y, find the concrete value that this variable must be constrained to because the equation dictates it, right? Variables in computing are quite different. They're a lot more malleable. So what a variable actually is inside of a computer system, and this is a very, very important concept, it's a chunk of memory, right? So RAM, your RAM chips? When you're working with a variable in a program, a RAM chip is an individual memory cell embedded somewhere inside of that RAM chip, right? So one of the interesting properties of variables that in programming that make them different from variables in algebra is they always have a concrete value, right? And there's a physical reason for this, right? So on the RAM chip, data in a computer is stored as a sequence of ones and zeros. You probably know this already. Technically speaking, that's actually high and low voltages, right? So a 0 is 0 volts, and a 1 is 5 volts or 3.3 volts or whatever the voltage level is of the circuit that you're dealing with. So the physical RAM chip itself, right, it must be either in a high or a low state, right? Physically speaking, it's either got voltage or it doesn't. There are only two states. There's no like quasi high intermediate state. There's no such thing inside of a computer. Not if the computer is functioning. So essentially what that means is that every variable must have some value. Now, whether that value is meaningful or not, that's another thing entirely. But every variable always has some value. So what an assignment operation does is it takes a particular location in memory and it puts a value into it, right? Whatever values you specify, normally that's the result of some other calculation. It can be the result of another calculation. You're going to see a number of examples here where we're just copying data between variables, essentially. But yeah, are there any questions about that? Because that's a very, very important fundamental concept. Normally, so we're going to do a few examples of flowcharts. These statement blocks, these instruction blocks, they're going to be memory operations of the type that I just described, right? So that's one type. The other type of block that we have inside of the flowchart is the conditional block. So a conditional block will contain some condition, and the execution of the program will diverge at the point of that condition. So if this condition turns out to be true, you go down the yes branch. If it turns out to be false, you go down the no branch. So this kind of plays into like the way that this is why flowcharts are a good analogy for programs. Programs can only do one thing at a time, and they sort of trace through the structure of a program in the same way that a flowchart does. So, you know, your program might be here, it goes to this statement block, executes it, then it continues and follows the arrow to the next one, executes that, follows to the next one, executes that. When it hits a conditional statement, it either goes left or it goes right, right? So if the program goes to the left, it doesn't care what the right is doing. If it goes to the right, it doesn't care what the left is doing, because you have selected a path through the algorithm, right? So the conditional statements themselves are often in terms of like real world algorithms, they're things like drum is full, gas tank is full, water is boiling, or water has reached a particular temperature, the molten sugar has reached exactly 114 degrees Fahrenheit, stuff like that. A more programmatic example, U is not equal to V. So, these flowcharts, as I've stated, instructions can follow each other in a sequence, in the same way that a flowchart does, and we sometimes use circles to indicate the stop and end point of an algorithm. Not often, though. Good. And I just want to point out one thing, which is kind of a pet peeve of mine, and I've noticed that it's like increasing, like I've been noticing this terminology increasingly, so I just want to set the record straight here. When you write a piece of code, right? If you open up a text editor, write some programming code, and it's a complete and coherent piece of programming code, that is called a program, not a code. Right? Code is the verb, program is the noun. I've heard a lot of people lately referring to, would you like to take a look at this code I wrote? And it's like, a few statements within a program, that is code, but the program itself is called a program. That's been annoying me lately, the way that people are referring to it. All right? So, when we have these, now that we've discussed the existence of conditionals, we have a few different things that we can do with them. These are the three main constructs. Essentially, if you understand the structure and behavior of these, these three sort of sub-flowcharts, then you can literally program any program that has ever been or will ever be. And I'm not exaggerating when I say that. Essentially, all programming code, no matter how convoluted or complicated or how many libraries it uses, is fundamentally reducible to the memory instruction that I talked about earlier and these three charts. So these are like, I don't know. If this was biology, this would be DNA. If this was chemistry, this would be the existence of molecules, right? These are the molecules of programs. I think that's a good analogy. So, has my chat just died, or is everybody just paying attention? Looks like everybody's just paying attention. I sometimes get suspicious when nobody's saying anything in the chat. So, good. Focused. Excellent. So, basic instruction. So, I've already talked, I think this slide should be a few slides earlier, which is why I talked about it. But The basic instructions of flowcharts are those which change the underlying state of the program. So you remember where we were talking about program state, right? And how the values that are in the various variables at various points in time, all of those are the states of the program. The way the program executes is by going from one state, performing an operation, and then producing the next state. And that a program might go through several million states over the course of its execution, depends on how long it takes to calculate something. So the states themselves are like the state. Another way of saying that is, what are the particular values which are held in all of the memory cells associated with the program that you're currently executing, right? So this is how you change the state, right? This is how you affect memory. So the assignment statement, again, fundamental statement. You know you're beginning to like become a real programmer when you don't even think about using assignment statements. They just flow from your brain. Let's see. Am I good? Okay. Listen, David. It's a program. Program. I'm not going to hear any of this code calling it a code nonsense. That's particularly like that. Actually, that's the bit that annoys me particularly, is the application of the indefinite article to the word code to mean a program. I'm a professor of computer science, goddammit. I'm allowed to have preferences on with respect to this. So we're going to be talking. So far we haven't really talked about Python very much. This guy right here, this is actually an artifact of Python programming particularly. You can perform multiple assignment statements in one line of code by comma separating the things you're assigning the values to and the values themselves. I don't think this is terribly important. It can make your code a little bit more compact if that, pleases you, but it's completely optional knowledge. David agrees. So, you can also perform arithmetic within assignment statements. So, generally speaking, the first one is the name of a variable or data structure, or many of the other things we're going to talk about as we progress through the course. But this is a variable, and this is an expression. Expression in a more mathematical sense, right? So essentially what the computer does is it takes whatever expression you've entered, looks up the concrete values of any of the variables you're using, computes the value of that expression, and then stores that in the memory location referred to by the variable name. So, good question. Is the colon before equals just a part of the language? So that is a part of the mathematical notation for assignment. Generally speaking, in actual programming languages, the colon is not including in Python. So in Python, it's just straight equals sign. But like, and this is a bit of a pedantic point as well. So when it comes to writing an algorithm, there are many, many, many languages you can use, and not all of them are computer programming languages, right? There is a specific set of mathematical symbols which refer to computing operations, essentially. And colon equals means assignment in math speak, basically. Again, normally when you're actually programming in Python or C or any C-based language, you're going to leave the colon out. I'm just going to pull up the example that we did last time in class and show you. So yeah, so this is the type of assignment statement that pardon me. This is an assignment statement. This is an assignment statement. This is an assignment statement. Notice the lack of colons. It's just equals. So there we go. Cool? We cool? Good. So let's consider the following. F4? Let's see. What is it? F6? No. F2? No. 1? No. Whoop. That's help. View. Full screen. Control Shift P. Control Shift F. Okay. Right. So let's describe an algorithm which computes the median of three numbers. So remember that the median is the middle of three numbers. So we start the algorithm with variables x, y, and z, and we assume that they have some concrete values. In this particular case, we're assuming that they're integers. But, you don't have to worry too much about data types just yet. So this is our algorithm. If x is less than y, we go down this path. If z is less than x, then we know that x is the middle, right? Otherwise, if z is less than y, we know that z is the middle. And if that is also not true, we know that y is the middle, right? If we go back up to the top, if x is actually greater than or equal to y, we go down this path. If x is less than z, then x must be the midpoint. If z is if not, then we check to see if z is less than y. If z is less than y, then y must be the midpoint. Otherwise, it must be z. So this is an example of a big if-then-else branch. Ooh, that reminds me, actually. I said these guys are so very important, then I failed to explain them. So let me return to these. Control Shift F. There we go. Right. So essentially, the three atoms of programming, molecules of programming, are the if statement, the if-then-else statement, and the while statement, right? Or the while loop. So with the if statement, which is just the plain if statement, we have a condition B, and we have a statement S. If B, then S. So if the condition B is true, we execute the statement S. Otherwise, we skip it, right? And we just continue on with the rest of the program as normal. The if-then-else statement has something to do on the no branch. So essentially, if and if-then-else behave exactly the same if the condition comes out true. However, if the condition comes out false, you execute whatever T is rather than S. So it's like this one skips if the condition comes out false. This gives it something else to do if the condition comes out false. Is there a reason or significance behind the flowchart always starting with a B in the diamond? Ooh, that's a very good question. Thank you, Omar. Yeah, it stands for Boolean. So we haven't talked about Booleans just yet, but Boolean is a data type. So it's a type of thing that a variable can contain. It's a type of thing that can result from the execution of an expression, right? So it's called, so Booleans are either true or false values, right? We refer to Boolean arithmetic, like there are operations you can perform on sets of Booleans to derive, you can derive other Booleans from them. But essentially, the condition is required to evaluate to a Boolean. So that's why it's called B here. So, if we consider this example, x is less than y. We know that we can, so long as x and y are things that it makes sense to perform less than with, right? It's like, if x and y are numbers, then that makes sense. If x and y are jelly beans, it doesn't necessarily make sense, right? So x and y being compared with a less than, that will result in either a true or a false statement, right? I know, in algebra so far, your experience of less than, greater than, will be as inequalities, right? It's like, we don't really think of, in algebra, we don't really think of less than as being an operation, right? It's more a separator between expressions that says something about the relationship between those expressions. But in computing, that is an actual operator. This gets computed. You actually determine whether or not x is less than y. If x is less than y, then you affect the calculation of the program based on that information. But it's always evaluatable because x and y will always have concrete values, right? Is this making sense for people? You guys following this so far? Let me ask you in a poll. Does this make sense? So if x is equal to y, it will just proceed to the right. That's correct, yeah. So x has to be strictly less than y in order for the yes branch to be followed. If x is equal to y, then the no branch will be followed, because x is not less than y, strictly less than y. You can also, less than or equal to is also an operator that you can use, but because it isn't used in this case, that's not how it works, right? Good. So let me talk about loops, because that's the other very, very important thing. So, repetition. So, a while loop, and while loops are kind of the prototype of all other loops. Pardon me. There are lots of different types of loops, but this is this is the prototypical one. We have our condition coming in, right? So we start off, we enter this condition. If this condition evaluates to true, then we execute some statement S. But in contrast to how the if-then-else statement works, we flow from this statement back up to before the condition, crucially. So this condition gets re-evaluated every time after each execution of S, right? So basically, we just continue iterating inside of this loop until such time as we hit this condition and it evaluates to false. Once the condition evaluates to false, we head down the no branch and break the loop. So loops are kind of tricky. Generally, at this level, loops are going to be the tricky thing that you need to wrap your head around. It's absolutely crucial that you understand how a loop works by assignment 2, right? It's going to be absolutely crucial that you come to an understanding of how a loop works and that you're able to use them practically. But yeah, so it's a conditional where you execute something but then return to the conditional unless that condition was false. And that's what a loop does. So, yeah, okay. So with this example, it is possible to annotate flowcharts But generally speaking, as you can see, it gets kind of messy, and you don't really need to. But yeah, reevaluate a new condition or data value. Oh, good question. So, very importantly, this condition doesn't change, right? The values of the variables will change. So you have to write the condition in such a manner that basically the thing that makes a loop tricky is that you have to write the statement sort of in tandem with the condition here, such that if you execute this thing enough times, this condition will eventually turn out to be false. If you don't do that, then you have a situation we call an infinite loop. And infinite loops break programs. So B could be is x less than 6, and the following operation to be add 1 to the number, and you would stop when it equals 6. Yeah, perfect, Daniel. Yeah, absolutely. In fact, I can code that one up for you real quick. So let's say x is equal to 0, while x is less than 6, x is equal to x plus 1, and let's just print x while we're at it, just to see that it is doing something. Right. Python 3. What is this? Topic 1. There you go. So you can see this loops through x having values 0, 1, 2, 3, 4, and 5. But when x is 6, this loop, this condition comes out false, right? Because x is no longer less than 6. So all of this is skipped, and it immediately goes down to whatever comes after the loop, which in this case is done, right? Listen, Julia. We're not talking about recursion yet, so, you know. We'll have plenty of time to talk about recursion later. Yeah, good. So, for example, if I were to make this x is less than or equal to 6, then I include 6, right? And if I were to set this as some kind of impossible condition, for example, if we start x at 7, right, and we try to execute that, oh, sorry. No, forgive me. So, if we start it, so if rather than counting up, we count down, that'll be a better example. You can see that it just counts forever, right? So this is what we call an infinite loop. And these things can and will break your program if you let them. Fortunately, I know how to interrupt them, because I'm an expert like that. Have I ever Googled recursion? I've never needed to. I just know what it is. I teach recursion. So, Google should ask me what recursion is. But yeah, no, yeah. So that's how a loop works, right? So this is a condition that you don't want, right? Because, if I wasn't printing out these intermediate values, this thing would just be, it would just hang, right? You would have what looks like a frozen program. It would just be executing forever. But, how do you interrupt them? From the command line, it's Control-C. Control+C, yeah. Recursion is more advanced than this lesson, but we will be covering it during this, course. We'll be covering it around topic 5, I think. So. So, good. So let's consider the following flowchart. This is a different example. So this example takes a series of numbers and computes both the maximum and the minimum of that. Julia, look what you started. You started a gigantic recursion discussion. So, so we get, so with this algorithm, we start off with 3 variables, I, min, and max. In addition to that, we also have integers ti for I between 0 and n. So we can take ti to be a series of temperature readings, right? So this is how we yeah. That's what happens when you take 1JC3 first. Wah, wah, wah. Yep. Yeah, absolutely. So this is how the algorithm works. We first check to see if I is less than n. I is how we access the individual elements of the temperature readings. So it's important that it doesn't exceed the number of temperature readings that we have. We then check to see if Ti is less than the current minimum. If it is, we set the minimum equal to Ti. We then continue, increment I. This is called an increment operation. Basically, anytime you add 1 to something, that's known as incrementing. So we put I, so we increment I, we then go back up, reevaluate the condition. If, however, T at I was greater than the current minimum, we then check to see if it's greater than the current maximum. If it is greater than the current maximum, we set the current maximum to Ti. Otherwise, we just skip it. So we iterate inside of that loop until such time as I exceeds n, or until such time as it's equal to n. Once that happens, we know that we're out of temperature readings, so we exit the loop. So let's very quickly, let's do an implementation of that in Python. So I'm going to use a list for this, which is not something that we're going to cover for a while, but it's more convenient syntax for this sort of thing. So this is something we haven't covered yet, but don't worry, we will. So def find min max, capitalize because that makes it easier to read. So we're going to take a series of temperature readings T. We're going to take a total number of temperature readings N. Yep. So the first thing we do is we set I equal to 1. We set min equal to T at 0. T at 0. We set max equal to T at 0. Next, we enter the loop. While I is less than n, we check to see if T is less than the current minimum. If T at I is less than min, we set min equal to T at I. Otherwise, we check to see if T at I is greater than the current maximum. If it is, we set max equal to Ti. Otherwise, we don't do anything. After all of this happens, we set I equal to I plus 1. We then return min and max. We'll talk about return statements later as well. So that's this algorithm here. A few important things to note. We're out of time. Okay, we'll talk about this more on Monday. Okay? Yeah. If there are any questions, please put those forward in the chat at this point in time. And otherwise, have a good weekend, folks. Could I have used elif? Yes, but we haven't talked about it yet, so I didn't want to use it. Oh, I suppose I should show you that this thing even works, shouldn't I? Find min max of the list. Just some quick data. There we go. And I'll just delete the 0 and make that so that that first element isn't the minimum. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. We use 0 indexing, incidentally, in computing, which I'm sure we'll have plenty of time to talk about. There we go. Execute. Oh, I should probably fix the infinite loop down here, shouldn't I? Before I do that. Yep. Okay. There you go. The calculated minimum is 2, and the calculated maximum is 8. There you go. So, questions. Let's see here. What does return mean? So, if you think about a function as being a sub-program, right? Up here, you specify the inputs. The return statement is how you specify the output. So, and that's essentially the long and the short of it. When you use a function like this, what you're doing is you're providing specific inputs, and it basically maps these into here, performs all of this, all of these instructions, and then these two values get replaced for this guy as the evaluated result, right? So using a function is very much like calculating an expression. The thing that you return from the function gets replaced in the expression with the result. So, like, for example, if I had a minimum here and I wanted to, say print 5 plus the minimum, that's all perfectly valid. Let me just execute that for a moment. Python 3, topic 1, there you go. See, it was 2, but now we get 7. So it calculates this guy, which means it goes into all of this, right? Returns the result that it's expecting, which is minimum, and then it replaces this with whatever value was calculated for a minimum, adds 5 to it, passes that to print, and then it prints it. So you get 7. There we go. What were the things I was going to note? I can't remember. Okay. All right. Thank you very much for your time and attention, folks, and see you next week. If you're bored over the weekend, I recommend trying out some of the coding bat problems, some of the early easy ones. Here, actually, why don't I show you? I'll give you some recommendations. Coding bat, Python. So, warm up. Yes. Monkey trouble. Yep. Yeah, I would say try this warm-up 1 problems. You probably warm up 2. You don't have enough to do that yet, but yeah. What happens if you print the statement that I wrote? Oh, you get 7. There, I've already produced the output. So we can't find question: can't we find max or min directly with Python? Yeah, actually, you totally can. You know, if you load up the Python interpreter, you know, if you find the minimum of, like, you know, 1, 2, 3, 4, 5, you know. So min is a built-in function that you can use. You can just use it. You know, if we just did that, there would be no, like, point in the learning exercise. You know, like I wanted to show you guys how an algorithm works. If I just give you the algorithm name, then that doesn't, you know, we're not to that point yet, I guess is what I'm trying to say. It's still very useful for us to break things down in terms of individual code constructs. So, anyway, take her easy, folks. Have a nice weekend.